Here in the section we have differentiation rules. Derivative of a constant function. If f has the constant value f of x equal to c, then derivative of our function with respect to x is equal to derivative with respect to of c. So the c is constant and the answer for this part is equal to 0, meaning that derivative of a constant is 0. Now here we have proof. We apply the definition of the derivative to f of x equal to c. So f prime of x, that is equal to limit as h approaches 0. Here in numerator we have f of x plus h minus f of x divided by h. So what we have here on this part, on x-axis, here we have x. Here this point is x plus h. This one is h is length of our interval. And based on what we have on x-axis, f of x is equal to c here, this point on y-axis, and f of x plus h. Here again, on y-axis we have same answer, and that is this constant, so it's c. So f of x is c, f of x plus h is c. So this is equal to limit as h approaches 0 is equal to c minus c divided by h. So that is limit h approaches 0. Here we have 0. C minus c is 0, so the answer is, our limit is 0. So we proved that our derivative of constant is 0. So derivative of constant equal to 0 is another way to say that the values of constant functions never change. So what we had based on these 2 points, f of x was c and f of x plus h again was c. So that never changed, and what that means the slope of horizontal line is 0 at every point. So here we have this horizontal line and the slope is 0. Derivative of a positive integer power, if n is a positive integer, then derivative with respect to x of x to the n power is equal to n times x to the n minus 1 power. So our exponent is n minus 1. So whether you have here on that part the power, here in this case is n, when we try to find derivative, we move this power to left side and using that as coefficient, and then for the power we have to subtract 1 from what was given here on this part. So instead of having n, here we have n minus 1. Now here I'm going to have proof for what I have here for this rule using this formula z to the n power minus x to the n power, that is equal to z minus x times z to the n minus 1 power plus z to the n minus 2 times x power is 1 plus, I'm using 3 dots, then plus, now the power that I have for z is 1, but power for x is n minus 2. And finally plus, here we have z power is 0. So having this one, that is equal to 1. I'm not going to write this way. I will have 1, so I will not write 1 here, but this is 1 times x to the n minus 1 power. So the formula that I have here can be verified by multiplying out the right hand side, then from the alternative formula for the definition of the derivative, f prime of x, that is equal to limit as z approaches x So our alternative formula is, here we had f of z minus f of x divided by z minus x. And that is equal to limit as z approaches x So what we have here is z to the n power minus x to the n power divided by what we have in denominator is z minus x. So what I did here in numerator was based on what our function was here on top. So here we try to find the derivative of x to the n power. So this x to the n power, that is our f of x. So f of x in this case is x to the n power. Finding f of z is z to the n power. So I use these two here on top numerator. So this one is equal to, based on what I have here, the left side, that is z to the n minus x to the n power divided by what I have here. So both sides divided by z minus x. If we divide by z minus x both sides, we're going to have z to the n power minus x to the n power divided by z minus x equal to, simplify that part, that will be equal to this part. So we're going to write this one here on this part. So we have z to the n minus 1, and we have to find limit. So that is limit z approaches x. So I'm writing what we have here on that part. Using 3 dots plus, and finally here we have z to the power of 0, so that is 1 times x to the n minus 1. So what I did here on this part, finding limit as z approaches x, so instead of z I used x. So we have x to the n minus 1, x to the n minus 2 times x. Then we have plus 3 dots plus, here instead of z we have x times x to the n minus 2 plus x to the n minus 1. Then here we have same base but different power, so adding our power, we have n minus 2 plus 1. In this case we have n minus 1. And then here we have plus 3 dots plus, on this part again, here power is 1, so 1 plus n minus 2, that is n minus 1. And then writing the last part, again we have x to the power is n minus 1. So how many times this part is repeated? That is n times. How we can say that that is n times? For example, here what we had on this part, this one was x power was 0. We're not writing that way because that is equal to 1. It doesn't matter what is your base. If your power or exponent was 0, that part will be equal to 1. So x 0 as a power, that is 1. So we're not writing that way because it's just 1 times z to the n minus 1. So here we started from 0 up to this point, n minus 1. So how many times this part is repeated? That means it's n times. So this means what we have here on this part, that is equal to n times x to the n minus 1. So this x n minus 1 is a power, that part, so this part is repeated n times. So multiplied by itself n times. This may be proved what we had here on top. So this is what we have in general. This is power rule, general version. If n is any real number, then derivative with respect to x of x to the n power, that is equal to n times x to the n minus 1. For all x where the powers x to the n and x to the n minus 1 are defined. Derivative constant multiple rule. If u is a differentiable function of x and c is a constant, then derivative with respect to x of c times u, so c is our constant, that is equal to c times derivative of u with respect to x. Now here I'm going to prove this one. Derivative with respect to x of c times u, that is equal to limit as h approaches 0 So assume that that is our function c times u, using what we have for alternative formula with f of x plus h minus f of x. But here in this case, instead of f, I'm going to write c times u. So cu of x plus h minus cu of x divided by h. So that is equal to limit of constant is equal to constant. So here is c times limit now what's left, we have u of x plus h minus u of x divided by h. So this is equal to c times what this part is, that is derivative of u with respect to x. So this may be proved what we had here on this part. Now here we have derivative sum rule. If u and v are differentiable functions of x, then their sum u plus v is differentiable at every point where u and v are both differentiable. At such points, derivative with respect to x of u plus v is equal to du divided by dx plus dv divided by dx. So now here on this part, what we have for our function is u plus v. So we apply the definition of derivative to f of x equal to ux, u of x plus v of x. So it's ux plus vx. So derivative with respect to x of ux plus vx, or u of x plus v of x, that is equal to limit as h approaches 0 So here we should have f of x plus h minus f of x divided by h. So that should be based on what our function is. So here in this case, f of x is ux plus vx, and f of x plus h is ux plus h plus vx plus h. So first, here we have f of x plus h. So it's u of x plus h plus v of x plus h, close this one, minus, now we have f of x, and that is based on what we have here, so it's ux minus vx divided by h. So the limit is equal to I'm going to write the first one based on u and the second based on v. So here I have u of x plus h minus ux divided by h plus v of x plus h minus vx divided by h so that is limit, writing each one individually. So we have limit of ux plus h minus ux divided by h plus limit of v of x plus h minus v of x divided by h. And that means here we have, for the first part, derivative of u with respect to x plus derivative with respect to x, and that is for v. So this way we proved what we had here on top. Now here we have derivative product rule. If u and v are differentiable at x, then so is their product u times v. And derivative with respect to x of u times v is equal to u times derivative of v with respect to x plus derivative of u with respect to x times v. So the derivative of the product u times v is u times the derivative of v plus the derivative of u times v. In prime notation, what we have, so the derivative of product u times v, that means u times v prime, is equal to u times the derivative of v plus the derivative of u, so it's u prime, times v. So this is what we have in prime notation, and then in function notation, here on this part, instead of product of u times of v, we have f of x times g of x. So derivative with respect to x of f of x times g of x, that is equal to f of x times derivative of g of x plus derivative of f of x times g of x. Or we can write f times g prime, that is equal to f times g prime, or f times derivative of g plus derivative of f, or f prime times g. So what we have here, this one, that is v prime, and this part here is u prime, and what we have here is u times v prime. Now here on this part we have derivative quotient rule. If u and v are differentiable at x, and if v of x not equal to 0, then the quotient u divided by v is differentiable at x, and derivative with respect to x of u divided by v, so this one is equal to v times derivative of u with respect to x minus u times derivative of v with respect to x divided by v squared. We can write this one in a function notation. So derivative of f of x divided by g of x with respect to x, that is equal to g of x times derivative of f of x, so here we have f prime, minus f of x times derivative of g of x, so here is g prime, divided by what we have in denominator, and square this one, so it's g squared. So this is what we have in function notation for quotient rule. Examples: find the first and second derivatives. Y is equal to 5x squared minus 15x minus 4 times x power is negative 4. So find the derivative of 5x squared minus 15x minus 4 times x to the negative 4. That is equal to derivative of each one of these terms individually. So derivative of 5x squared, that is equal to, so this one is using this rule, derivative constant multiple rule. So in that case we have 5x squared, and we're going to have 5 times the derivative of x squared. I'm going to write all steps. So writing this constant first. So 5 times derivative of x squared minus, now here our constant, we have negative 15 derivative, here we have x, then on this part we have negative 4, that is our constant, So now this is equal to, so x squared, finding derivative, that is 2 times x, and 1 is our power. Then derivative of x is 1. So we have to move this power to left side. So writing that here, 2, and then we have x, and our power will be 2 minus 1. So we're going to have 1 as a power here for this part. And we have to multiply by 5. So that means we're going to have 10x. Without writing the second row, starting from this point, we can use that power, multiply here. So 2 times 5, 10, and then multiply by x, power will be 2 minus 1. So 2 times 5, 10, x, power 1. So it will be same answer. Now here we have negative 15 times, this one power is 1. So move that one here to use as a coefficient. So it's 1 times x, power is 0. So this is negative 15 times 1 times x, power here is 0. So writing all steps. Then we have negative 4. So here is negative 4 times negative 4 times x, power is negative 4 minus 1. So it's negative 5. Now what is our final answer? We have 10x minus x to the 0. It doesn't matter what base you have. If power was 0, if exponent was 0, the answer for this part will be 1. So that is 1. So what they have here is negative 15 times 1. So that is negative 15. Plus negative 4 times negative 4 is positive 16. And here power is negative 5. So this is final answer for first derivative. We can also write our final answer having positive power in denominators. Instead of having negative power negative 5, I moved that power to denominator to make that positive. So instead of having 16 times x to the negative 5, we have 16 divided by x, power is 5. So these two are equal. It's the same answer. Now finding second derivative of 5x squared minus 15x minus 4 times x to the negative 4. That is equal to first derivative of what we had here on this part. So second derivative of y, that is same as finding first derivative of what we had here for our first derivative. So that means this one, if we find the answer for that part, that is second derivative of y. So this is equal to finding derivative of each one individually. So here again, I'm writing all steps. So here we have constant is 10 times derivative of x. Here derivative of constant is equal to 0. But here we can write this way, negative 15. Derivative of what we have here is x, power 0. But we don't need to write that way. But I'm writing that way because I'm writing all steps. So plus 16 times derivative of x, power negative 5. So now what we have here, on this part, power is 1. So move that to left side. Now we have 10 times 1 times x power is 1 minus 1 is 0. Now here negative 15. Now here we have 0, so it's 0 times. So negative 15 times 0 times, it doesn't matter what you have here, we're going to have 0 minus 1, and that will be x power negative 1. So the answer for this part, that part will be 0. Then plus 16 times, move this one to left side, that is negative 5 times x power is negative 5 minus 1, that is negative 6. So what our final answer is x power 0, that is equal to 1. So here we have 10 times 1 times 1, so that is 10 minus, here we have 0, negative 15 times 0 times x is negative 1, that is 0, so I'm not going to write that part. Then 16 times negative 5, that is negative 80 times x power is negative 6. And we can write this one equal to 10 minus 80 divided by x power is positive 6. So these two are same. Find y prime by part A applying the product rule and part B multiplying the factors to produce a sum of simpler terms to differentiate. So y is equal to 4 minus x squared times x cubed minus 4x plus 1. What we have for part A, apply the product rule. Let u equal to 4 minus x squared and v equal to x cubed minus 4x plus 1. So derivative of u times v with respect to x, or derivative of y with respect to x, that is equal to derivative of 4 minus x squared times x cubed minus 4x plus 1. So that is equal to 4 minus x squared times derivative of x cubed minus 4x plus 1 plus x cubed minus 4x plus 1 times derivative of u, which is 4 minus x squared. So this is equal to 4 minus x squared times derivative of x cubed minus 4x plus 1, that is 3x squared minus 4 plus x cubed minus 4x plus 1 times derivative of 4 minus x squared, so that is negative 2 times x So here I multiplied and combined log terms. So this is our final answer. So our final answer is negative 5 times x to the 4th power plus 24 x squared minus 2x minus 16. Now here in part B, multiply the factors of the original expression u and v to produce the sum of simpler terms. So here I multiplied and combined log terms. So this is what we have for y, negative x to the 5th power plus 8 times x cubed minus x squared minus 16x plus 4. Now finding derivative over y prime, that is equal to, so move this one to the left side, we have negative 5 x power is 5 minus 1, so here we have 4 plus 3 times 8, we have 24. X power is 3 minus 1, so that is 2. Then here power, move that to left side, meaning that we have to multiply 2 times -1, so that is -2. X power is 2 minus 1, so that is 1. Minus, here power is 1, so 1 times -16, we have -16. And here we're going to have x power is 0, so that part is, this part is 1. I'm not going to write that. And derivative of this constant, that is 0. So that means our final answer is this one, which is exactly same as what we had here on top. Find the derivative of the following function. F of t is equal to 3t squared minus 8 divided by 2t squared plus 17 minus 4. So here f prime of t, that is equal to the derivative of 3t squared minus 8 divided by 2t squared plus 17 minus 4. And this is equal to what we have here in the denominator, 2t squared plus 17 minus 4 times derivative of what we have in numerator, so derivative of 3t squared minus 8. Then subtract, so here we have subtraction, so minus what we have in numerator, 3t squared minus 8 times derivative of denominator. And the denominator is 2t squared plus 17 minus 4. And finally, what we're going to have here in the denominator is 2t squared plus 17 minus 4 squared. Now find the derivative. So this is equal to, here we have 2t squared plus 17 minus 4 times derivative of 3t squared minus 8, that is 2 times 3. So 6t power is 2 minus 1. So here we have derivative is 6t minus 3t squared minus 8 times, finding derivative. So we have 2 times 2, here is 4t plus 7, derivative of -4, that part is 0. And divide by what we have in denominator. Now we have to simplify what we have on top, numerator. So I multiplied what we had in numerator and subtracted, combined like terms. So this is what we have after combining like terms. It's 21t squared plus 8t plus 56. And rewriting what we had in denominator. So denominator is 2t squared plus 17 minus 4 squared. So here is our final answer. Find the derivative of the following function. Y is equal to 6t minus 1 times 5t minus 5. And here power is -1. So here we had a negative power. I try to have positive power instead. So instead of 5t minus 5 to the -1, I moved that to denominator, this negative power moving to denominator to make that positive. So here in denominator we have 5t minus 5 and power is +1. So here f prime is equal to derivative with respect to t of 6t minus 1 divided by 5t minus 5. So that is equal to 5t minus 5, so that is what we have here on this part, times derivative of what we have in numerator, 6t minus 1, minus 6t minus 1 times derivative of 5t minus 5. And finally, in denominator, we have to use this part, 5t minus 5, and then power for that part would be 2. So it's 5t minus 5 squared. Now finding derivative. So here we have 5t minus 5 times derivative of 16 minus 1 is 6. Derivative of 5t minus 5 is 5. Rewriting denominator. So what we have in numerator, multiply, combine like terms. What we have on top is negative 25. So the final answer is negative 25 divided by 5t minus 5 squared. Find the derivative of the following function. Y is equal to 7 plus 2x minus 6 times square root of x divided by x. So here on this part, the f prime of y, that is equal to derivative of 7 plus 2x minus 6 times square root of x divided by x with respect to x. And this is equal to, same as what we did on the last one. So f prime of y is equal to derivative of 7 plus 2x minus 6 times square root of x divided by x with respect to x. So that is equal to what we have here in denominator, x times derivative of what we have in numerator. So derivative of 7 plus 2x minus 6 times square root of x minus 7 plus 2x minus 6 times square root of x, so that is what we have in numerator, times derivative of x divided by x squared. So here on this part we have to find derivative of square root of x. Note that a derivative of square root of x for x greater than 0 is 1 divided by 2 times square root of x. And how we got that one? So square root of x is equal to x to the power is 1 over 2. So power is 1 over 2. Using this one to find derivative, we should move this power to the left side and use that one as coefficient. So we're going to have 1 over 2 times x, and we have to subtract 1 from power. So we have 1 over 2 times x, power is 1 over 2 minus 1. That means power is negative 1 over 2. I don't want to have negative power, so I'll make this one positive by moving this to denominator. So that is equal to 1 over 2 times 1 over x to the 1 over 2 power. So our power here in denominator is 1 over 2, meaning that this part is square root of x. So recall that what square root of x is. Here power is 1 and here index is 2. So writing what we have inside radical x, this one is on top, and denominator is our index. So now using what we had here on that part to find derivative. So here we have 2, derivative of 2x is 2 minus 6 times 1 over 2 times square root of x minus 7 plus 2x minus 6 times square root of x multiplied by derivative of x, and that is 1 divided by x squared. Now we have to multiply and simplify what we have in numerator here. We have this part in denominator, so I'm trying to clear fraction. So here we have to multiply both numerator and denominator by square root of x. So multiplying 6x divided by 2 times square root of x by square root of x, both numerator and denominator. So here on top we have 6x times square root of x, and denominator is 2 times square root of x times square root of x is x. So simplify here, 6 divided by 2, that is 3, x divided by x is 1, and we have square root of x. So this is what we have for that part. It's 3 times square root of x. So this is what we have here in numerator. Now combine like terms. So here combining like terms, or what we have as negative 7 plus 3 times square root of x divided by x squared. Now we have to simplify, so this is negative 7 divided by x squared plus 3 times square root of x divided by x squared. I multiply both numerator and denominator by square root of x to be able to simplify this part. So we're going to have 3 times x divided by x squared times square root of x. We can cancel x, and that means that we will have 3 divided by x times square root of x. So this is our final answer. We can also find the answer without using this rule, this quotient rule. So I'm going to write that one here. So the derivative could also be found without using the quotient rule by writing (7 plus 2x minus 6 times square root of x divided by x) as 7 divided by x plus 2x divided by x minus 6 times square root of x divided by x. So simplify and then differentiate each term individually. I try to find the answer using quotient rule, but the point is that you can also find the answer using this method. Find the derivative of each one. So derivative of 7 over x. Here we have, so simplify that one, that is 2. Derivative of 2, and so here I simplified, and what we have is 7 times derivative of x power is negative 1 minus 6 derivative of x power is 1 over 2 times, here we have x power is 1, so moving that on top, we have x power is negative 1. Now that we have same base, we can add powers. So meaning that here power is negative 1 over 2. And now finding derivative. So move this one to left. We have negative 1 times x power is negative 1 minus 1, so that is negative 2. And the same thing for this part. Moving this one to left, we have negative 1 over 2 times x power is negative 1 over 2 minus 1. So that is negative 3 over 2. Now simplify, so our answer is negative 7 divided by x squared plus 3 divided by x, and power is 3 over 2. So this is equal to negative 7 x squared plus 3 divided by x power 3 over 2. It's same as what we have here on that part, because this is 1, and square root of x is same as writing x power 1 over 2. So here we have x times square root of x. Again, this is x to the 1 and times x to the 1 over 2. So this is our final answer. Find the first and second derivatives of the function w equal to 2 plus 5z divided by 5z multiplied by 5 minus 3z. So here I multiply what I have in numerator and then combine like terms. So w is equal to negative 15z squared plus 19z plus 10 divided by 5z. Now divide, so we have negative 15z squared divided by 5z, it's negative 3z. 19z divided by 5z, it's 19 over 5. And positive 10 divided by 5z is 2 divided by z, or 2 times z power is negative 1. Now finding derivative of each one of these terms individually. We have negative 3 times derivative of z is 1 plus derivative of 19 over 5 is 0 plus 2 times derivative of z power negative 1. So we have negative 1 times z power is negative 1 minus 1, it's negative 2. So this is equal to negative 3 minus 2 z negative 2. So I'm going to switch order because I want to have the part that has power first. So negative 2 z power negative 2 minus 3. So this is final answer for first derivative. Now we have to find second derivative. So now our second derivative that is equal to derivative of what we had here for first derivative. So differentiate each one of these terms. So I'm writing all steps. Here, derivative of negative 3, that part is 0. But I'm writing all steps, so having 0 or that is same as having negative 3 times derivative of z power 0. So this is equal to negative 2 times, move this one to left, it's negative 2 times z power is negative 2 minus 1, so this is negative 3 minus 3 times derivative of 1 is 0, so this part is 1, and derivative of 1 is 0. So the answer is 4z power is negative 3 minus 0. So this is final answer for this part. For second derivative, here again it's asking to find first and second derivatives of the function. P is equal to 3 times q squared plus 27 divided by q minus 3 cube plus q plus 3 cube. So I'm not going to find derivative based on what is given here on this part first. I will try to simplify. So what I did here, I simplified by writing q minus 3 cube and what we have for q plus 3 cube in denominator, combined like terms. So in denominator we have 2q cube plus 54 cube. Again, we can simplify. So we have 2q, that is a common factor in denominator. So factor out that part. It's 2q times q squared plus 27. Now we can cancel that part from numerator denominator. So what we have for p is 3 divided by 2q. So instead of finding derivative for that part, we only need to find derivative for this one, 3 divided by 2q. So the answer that I have here for p was 3 divided by 2 times q. I can also write that equal to 3 divided by 2 times q to the negative 1 as a power. So it's 3 over 2 q negative 1. Now finding derivative of p with respect to q. So this is equal to 3 divided by 2 times negative 1 times q power is negative 1 minus 1, so that is negative 2. So what we have for this part is negative 3 divided by 2. I can move this negative power to denominator, making it positive. So it's q squared. So this is what we have for first derivative. Now finding second derivative. So second derivative of p is equal to first derivative of this part. So we already had first derivative of p, so using that one to find second derivative of p. So this is equal to derivative of negative 3 divided by 2, q negative 2 is our power. And then finding derivative, we have negative 3 divided by 2 times, moving this one to left, so we have negative 2 times q power is negative 2 minus 1, so that is negative 3. Now simplify. So here, negative 3 divided by 2 times negative 2, that is positive 3, times q power is negative 3. So the final answer is 3 divided by q and power is 3. So this is final answer for second derivative. And this one was for first derivative.